So this is part 2 of complex numbers, and complex numbers, of course, are imaginary numbers, and they are complex because they are imaginary and real, a combination of both. They come in the form of A plus BI, where A is the real part and BI is the imaginary part. So the good thing about imaginary complex numbers is that they behave just like other variables do when we are adding or subtracting. So if we have 5 plus 10i plus 3 minus 2i, then we can just add the like terms and get 8 plus 8i. Also wanted to let you know that we can also deal with imaginary numbers on our calculator. So on your calculator, you can access imaginary numbers, complex numbers. But the first thing you have to do is your calculator has to be in the right mode. So in order to deal with that, you have to be, you see if you hit the mode key, there's real, and then there's A plus BI. You need to be there. So I am there, so I just wanted to show you that we could actually add these together on your calculator. Not that that would really be necessary. So to get to the I key, it is the second function of the decimal key. So you would need to, be sure this is focused, you would need to say 5 plus 10i plus 3 minus 2i. And that would give you 8 plus 8i, which is exactly what we got. So we can add, subtract, multiply, and divide complex numbers on our TI-84 calculators, which is super handy. So back to adding and subtracting here. So adding and subtracting these complex numbers at the bottom. Remember, if we have a minus sign that directly precedes parentheses, we've got to distribute the negative 1. So negative 7 minus 3i minus 8 minus 3i, which this is going to give us negative 15 minus 6i. Just a reminder that yes, they all come in the form A plus BI, and that is the standard form of a complex number. Multiplying complex numbers, we have to think about the powers of I that we discussed in the last video. So if we are going to distribute 7i times 8 minus 3i, we will get 56i minus 21i squared. And of course, every time we see I squared, we are going to substitute in negative 1. So this is the same as negative 1. So 56i minus 21 times negative 1, if we follow order of operations, this will become positive 21, which now we need to use the commutative property and put it in correct form, 21 plus 56i. So both of those are correct, but 21 plus 56i is the standard form of the complex number. And once again, we can do this pretty quickly on our calculator. So we could say 7i times 8 minus 3i. And it will give us the correct answer in the standard form of a complex number, 21 plus 56i. This is a binomial times a binomial, A plus BI times A plus BI. We need to use the FOIL method here in order to simplify this expression. So 5 times 4 is 20, 5 times 7i plus 35i, negative 3i times 4, negative 12i, negative 3i times positive 7i, negative 21i squared. And of course, every time we see I squared, we know that that's going to get a negative 1 subbed in. So the easiest way to deal with that is this minus 21i squared is simply going to become plus 21 on the end. So now we can combine like terms. 20 plus 21 is 41. positive 35i minus 12i is plus 23i, and that is our answer in standard form. 2 more quick problems. Division of a complex number. Since, by definition, the square root of -1 is equal to I, we need to rationalize the denominators and not leave an imaginary number or a complex number in the denominator of a fraction. So 2 different ones here. On the left, we have a monomial expression, 3i. On the right, a binomial expression. So on the left, all that we truly need to rationalize is just the I. Don't worry about the 3. So we're going to multiply by I over I. And remember, I over I is equal to 1. That's the multiplicative identity. So when we multiply by 1, we don't change the value. But we will rationalize this denominator. So 5 times I is 5i. 3i times I is 3i squared. And of course, everywhere we see I squared, we substitute in -1. So we rationalize this denominator by multiplying by I over I, and we end up with 5i over -3. Or you could just say -5i over +3. They mean exactly the same thing. On the right, we have a binomial in the denominator of the fraction. So in order to rationalize a binomial expression, we saw this in a previous video, we need to use a conjugate, and in this case, a complex conjugate. So 2 minus 5i is in the denominator. We need to multiply both the numerator and the denominator by 2 plus 5i over 2 plus 5i. Once again, that's called the complex conjugate. And a binomial times a binomial demands that we use the FOIL method. So 7 times 2 is 14. 7 times 5i plus 35i. 4i times 2 plus 8i. 4i times 5i plus 20i squared. I times I to the first times I to the first is giving us the I squared. All over complex conjugates, 2 times 2 is 4. 2 times positive 5i plus 10i. Negative 5i times 2 minus 10i, and that's the whole purpose of using the complex conjugate, is that the middle terms are going to cancel. A negative 5i times a positive 5i is negative 25i squared. So once again, everywhere that you see an I squared, you need to substitute in its value, which is -1, times -1 times -1. Now, they don't cancel. Remember, we only can cancel after we factor. But we can combine like terms. So first of all, 20 times -1 becomes -20. Negative 25 times -1 becomes plus 25. So now in the numerator, 14 minus 20 is -6. 35i plus 8i is plus 43i, all over 4 plus 25, which is 29. And -6 and 43 do not have a common factor, therefore nothing will factor out, therefore nothing will cancel. So this is your brief video for treatment of complex numbers.